the problem solving. Okay. So Encik Amin here. Oh, sama macam tadi soalan kita. Amin juga ni pun. Okay. So Amin traveled 405 km on 45 liters of petrol in his car. If Amin wished to go to a place which is 198 km away by car, how much petrol in liters does he need? Solve this problem through mathematical modeling. Just now, we have three. Linear, quadratic, and exponential. Okay, so if you look over here, we are going to identifying and defining the problem. This means the volume of petrol required for 198 km. We know the far lah. We travel, the more petrol we require, thus the amount of petrol varies. Okay, so we are going to use what this one? Variation. This is going to be various directly. How did we know? Okay, so over here we have that for 405 kilometer, okay, Encik Amin will use 45 liter. So means that if he want to travel 198 kilometer, so how much petrol did he need? So we are going to use over here, X is going to be our distance travel, and Y over here is going to be our amount of petrol required. So we are going to have over here Y is varies directly with our X over here. So we are using our variation. Okay, varies directly. Y equals to Kx. So we are going to apply mathematics to solve problems over here. Substitute y equals to 45 and x equals to 405 into y equals to kx, means that we are going to find our constant k. So k here is 1 over 9. Then we are going to use the same variable, but we are going to substitute with the value of our x, 198 kan? Sebab tadi dia tanya 198 km kan? How much of petrol, means that we are going to find for our y over here. So we are going to have y equals to 1 over 9 times with 198, means that 22 liters of petrol is required to travel 198 kilometer. Lagi apa lagi? Oh, verifying and interpreting solution in the context of the problem. We may not be able to use the linear function model in all situation. Oh, this one apa? Dia tengok ni lah, dia punya assumption yang kita tadi tu. Towns and city dia akan berbeza kan? Okay. Thus the car will use up petrol at a faster rate in the first route compared to the second route. Why? Sebab apa? Sebab town lagi habis dah ke? Belum kan? Okay. When this is translated to the real world situation, the linear function model obtained is not suitable to solve this problem. It's not suitable lah. This one only on paper je lah. Kan? Sebab we cannot apply dekat mana? If we dekat luar. Okay, if we compare with different place. Maybe kalau dekat town lain, dekat apa? Hutan pula. Dekat kampung lah, janganlah hutan. Hutan tak ada jalan kau. Okay. Refining the mathematical model. Okay, so we are not able to refine the model due to limited. Nampak tak? We are not able to refine the model due to limited information given. Nak report? Yes. We are going to report the finding of problem based on the interpretation of solution as shown in the preceding section. So, that's going to be our example 2. Okay. For example 3 over here, the diagram below shows the cross-section of a river. Hydrologists measure the depth of the river y meter. So, y here is going to be the depth of the river. And then at different distance x meter from the river bank. X over here is going to be the distance here from our river bank. The result obtained are given in the following table. Ini cross section of a river. River. So river, you are going to have, kalau kita buat dia punya keratan rentas, river sini makin rendah, turun, sini agak-agak dia akan apa? Makin naik balik lah kan? Betul tak? River, you ada hulu dengan hilir. Ya, hulu hilir tak tahu, okay, tak apa. Okay, so that's why we are going to have start with 0, and then if you look at the depth there, when we are going to have the distance there, we are going to depth of the river also 0. Why? Sebab dia makin ke darat balik lah. Darat, dia turun, pergi dekat dasar, lepas tu dia pergi balik ke darat. Kan river kan? It's not the sea. Okay, sea besar sangat. Okay, so show how the hydrologists use the data above to determine the depth of river through mathematical modeling. So, identify, we are going to determine the depth of the river, making assumption. So, assume the river is the deepest in the middle. Sebab ada jugalah apa, river yang macam ni kan, dia punya tanah tak rata apa semua. So we are going to assume that our river here in the middle is going to be the depth, the deepest one. Okay, the two variables involved in the study are the depth of the river y meter and the distance of the river bank x meter. Oh, dia guna kuadratik. Okay, applying mathematics to solve problems. So means that from our table just now, from the table just now, we are going to have our okay, we are going to have our quadratic function. So if you look here, x is going to be the distance, y over there is going to be the depth of our river. Okay, so x, y over here. How did we got our graph? Ni x, y, ni x, y, right? There, you are going to have x and y. X for our x-axis, which is the distance of the river bank, and y, depth of our river over here. That's why you are going to get the quadratic graph here. Okay, based on the graph, the depth of the river is 3 meter. How did we know? Kalau tengok dekat sini pun dah nampak dah. Paling, 2.9. Maksudnya dia pergi sinilah ni, 2.9. So means that we are going to have the depth over here is going to be here. Dekat 15. Kan?
Ya, betul.
Ya, betul dah. Over here, the middle. Sebab dia kuatkan 4 dah kelas. So means that 10 square is going to be 4. 1 square, small square, is going to be 0.4 kan? Betul tak? So means that over here, ni, tengok graf awak. Tengok graf awak. How did the questions know is going to be 15 there? By looking at the graph, saya dapat tengah-tengah kan? So you are going to have over here this one. So how many boxes there? We are going to get 1, 2, 3, 4, 5, 6, 7.5. 7.5 times 0.4? 0.4, 3. So 12 plus with 3? 15. That's why our answer here is 15 there. Kan? Boleh? 15, 3.0. Okay, so the deepest one is going to be 15 meter from our river bank. Okay. Ini dia punya ni rumus. Okay, because why? Just now we have what graph over here? quadratic. So we are using quadratic function. Ax squared plus bx plus c. So where do we have our constant a, b, c over here? We are going to look from the graph. Okay, the data 0, 0, 25, 1.7, 30, 0. Kalau tengok dekat sini, ambil dah salah satu ni. We got over here 3. 0, 0. Okay, kalau tengok sini 0, 0. Lagi dia ambil berapa tadi? 25, 25. 1.7 over here and 30, 0. X, Y, S, Y here. Okay, dia ambil yang tu. Okay, from that, we are going to have two linear equations, then substitute. We are going to find all the value for A. We have over here value for A. Then substitute. You are going to get the value of B. Where B? This one. And the value of C is going to be, where's value of C? Nampak C tak? Where's C?
C, wait, this is 0.
Oh, C is over here. This one lah. C equals to 0 kan? Okay. So hence we are going to have over here. Okay. Substitute X equals to 15 into our substitution over here. Y equals to negative 0.0136. X squared is going to be A there. Plus with 0.408 is going to be our B. Our C tak ada sebab 0. Okay. So we substitute this one with the value of X with 15. If you look over here, X is 15 into our calculation over here. We are going to get 3.06 as our Y. Okay. So if you look over here for this model, we assume that the river is the deepest in the middle. This may not be true for some other river. So means that a new model will be needed if we have new assumption. The answer will be more accurate if more data has been collected. Report the finding, write a full report. Itu saja. Okay. This one example 4. Masa saya nak habis dah. Okay, example 4 you can look for yourself. Example 4 over here. Okay, self practice now. Please open your Nilam book. We are going to solve the mathematical problems. Okay. So what we have over here? Please open to the page 193. Okay. Rajendran hobby is cycling. Rajendran takes 3 hours 12 minutes to cycle 44 kilometer. 2 hours lah. Oh, saya kata 3. 2 hours 12 minutes to cycle 44 kilometer. If Rajendran want to cycle 32 kilometer, how much time does he take? Solve the problem through mathematical modeling. So, the first step here, identifying and defining the problem. So, what should we identify over here?
How much time?
Time kan? We are going to find, okay, first one over here. We are going to determine the time taken for 32 kilometer for cycling, for cycle 32 kilometer kan? For cycle 32 kilometer. Defining the problem. Means what we have over here. Is it Rajendra will take more or less than 2 hours over here? Why? So, what can you say that one? Logically. Dia guna logic Makin jauh, makin lama. So, makin dekat,
Makin cepat.
cepat. So, apa dia tu?
So itu
Variation lah. Yalah, kita boleh kata apa? Kalau variation dekat sini, kita kata apa? Tadi baru kamu kata, makin jauh, makin lama. So, we can say that
the further the distance.
yes. So, if we are going to say the further the distance, you are going to get the more time, isn't it? Time taken also is going to be what? Tinggi. So, if we have over there 32 kilometer, means you are going to get we are going to get lesser than 2 hours and 12 minutes over here. That's going to be define our problem, isn't it?
Yes.
Longer the distance, longer the time taken. So it's going to be next we are going to have our second one. Okay, second one is going to be what? Alamak, saya tak ada Saya tak ada dekat sini. Alamak. Tak ada, tak apa. So the second one is going to be making assumption. Okay, so how we are going to making assumption? Assumption. First, we are going to say that what? Same bicycle. Okay, no problem. Same bicycle. Same bicycle. Same route. Okay, no problem. Same route. Yelah, nanti takut lain pula kan, route yang lain. Apa lagi? Weather, yes. Yelah, nanti ada orang kata cikgu panas, cikgu hujan. Cukup lah kan? Cukup lah tu. Making assumption over here. Okay. Now, we are going to have our variable. What can you have over here for our this one variable? Make identifying our variable. Okay, we are going to have distance first, isn't it? We are going to have our distance. Lagi apa lagi? Distance is going to be D, and we are going to have our time taken over here is going to be T. Boleh? Okay, that's going to be identifying variable. Okay, next. Number 3 is going to be applying mathematics. So, what can you have over there just now? Variation. So, if we are going to use our apply mathematical model over here, applying mathematics, we are going to apply what? Variation. So, how you are going to varies directly, betul tak? Varies directly. So we are going to say over here that D equals to K lah kan? Okay, if you are saying like this, pun boleh. D varies directly with T kan? So means that if we are going to apply mathematical model over here, we are going to have D equals to KT. Right? So just now we have our distance. What? 44 kilometer. This one. Distance 44 kilometer. Time taken is 2 hours 12 minutes. Boleh tak kita nak tukar? Tukar kepada hours ke tukar kepada minit? Senang. Hours. Okay. So we are going to have over here for our distance is 44. Our time is 2 hours and 12 minutes, 2.2 hours. Okay, so we are going to have over here, find our constant K, betul tak? Kan? Okay, so means that K here is going to be distance 44 divided by 2.2. What do you get? 20. So that's 20 apa? 20 hour? Constant. Constant. Yelah, cari constant dulu kan. So that we know we have what over here we are going to find for 32 kilometer kan. So now we are going to use our distance here is going to be 32. So we are going to have over here to find our time. Means that you are going to say what? Time over here. Okay, sorry. Saya akan buat D equals to 20T. Betul tak? Kan? That's our constant kan? That's our variation kan? So we have already that D here is 32 equals to 20T. So if I want to find my time over here, yes, T here is going to be 32 divided by 20. Berapa dapat? 1.6 hours. So we are going to have 0.6 times by 60. So 1 hour and 36 minute. Kan? Faham tak ni? Variation. We are going to use applying mathematics over here. So for number 4. Number 4, step 4. What is step 4? Verifying. Okay, verifying and interpreting solution. What can we say over here? This is going to be what? This is going to be what did we have over here? D equals to KT. Variation. Tadi dekat dalam kamu punya buku teks ada. Apa tu? Kamu akan dapat apa? Linear. Dia menaik lah. Just now kan kita dah bagi tahu dekat sini. Kelas. How did we know this is going to be linear? If we using our graph. Kalau. Adalah bawah ni saya punya. Ya ilaha illallah. Tak apalah. Sabar je lah. Adalah. Mana nombor 2 tadi? Tulisan dah lah cantik Tak apalah. Tak apa. Kita pergi nombor 4 sini sini nombor 4. Okey, nombor 3 kat atas. Sorry, adalah. Oh, saya tahu kenapa jadi macam tu. Sebab tadi apa Okay, so if we are using this one, if you are compare with our textbook, okay, we are going to have what? Graph. Linear graph, isn't it? Why did I say linear graph? If the for our what we call distance over time, isn't it? Distance and time over here. So you distance distance and time mesti bawah lah kan. Okay, so we are going to get linear graph. Why did we got linear graph? Directly proportion over here. So we are going to have over here that D equals to 20. Graph over here you are going to get D equals to 20 T kan tadi? Tuh. Kan. D equals to 20T. So we are going to get over here verifying and interpreting solution in the context of the problem over here. We are going to get our linear function kan? Betul tak? Okay, so refining the mathematical modeling. Okay, so refining ni kita play safe. If you look at the play safe lah. If you look at the refining ni, selalu ni dia akan kata apa? Mana dia? Tadi yang kita punya tu. This one. In this problem, we are not able to refine the model due to limited information given. Play safe lah ni saya kata play safe. Sebab yalah, we are not going to have the mathematical modeling here. We cannot apply to all the situation. Yalah. Saya tak kata pun tiru So just here we are going to say we are not able. Ni salin. Saya tak kata tiru. Saya kata salin. Okay, we are not able to refine the model due to limited information given. And last but not least, reporting the finding. We also can say that report the finding of the problem based on the interpretation of solution as shown in the preceding section. Itu pun boleh. Pakai yang tu je lah. Kan kelas? Tak ada buku teks ke? Bagusnya. Kan cikgu dah bawa buku teks untuk kami. Okay, so I have another 4 more minutes over here. I stop first.